Hello everybody and welcome back. I wanted to give a short update on the status of the laser. I've done a bit of work. In fact, I've done a lot of work on it. I've already showed the ammeter and that is working out really well. And as a new feature right up in the front here, I have two temperature gauges which record the temperature of the water going back to the chiller on the outside of the tube, so it's always quite a bit higher than what the real water temperature is, and the temperature of the laser tube at the exit mirror. This is the part that you don't want to get hot. If the laser tube starts heating up there, basically then you're in trouble because you've ruined your tube. And it records those temperatures really nice, and I've done it with some really cheap temperature sensors. I've checked them to find out if they're if they present the same temperature, so I had them joined at the sensor for several days, and they were like within 0.1 degrees of each other, which is cool. And if they run out of batteries, I can just swap the batteries or get new ones. I think they're so cheap, it's cheaper to get new ones than to replace the batteries, but I'm still going to do the batteries. I've went through a lot of different materials, starting from 3mm plywood, going up to 12mm MDF, and I've done a lot of stuff. And the cool thing is the chiller modification with the new chiller controller is an absolute improvement. The laser's been running for about 10 hours and the chiller was basically running all the time, and as soon as I turned it off, the chiller went off, and it's been silent ever since, only coming on like, I don't know, every 10 to 15 minutes. And it is one of the hottest days of the year here. Even in my basement workshop, it's over 25 degrees Celsius, and that almost never happens here. One of the most work-intensive modifications here was I do have a new fume extractor with a 220 volt fan, and it originally came with one of these really cheap speed controllers, which is basically a dimmer circuit made for these big fans. And yeah, if I turn this down all the way, the fan was still running at 80 watts, which was way too much for me. And this thing was getting hot till about I don't know, 45 degrees Celsius, with over 80 degrees inside, so that was a real no-go. So in the end I went for a multi-stage transformer, and I now have 4 speed settings, and it is from silent to absolute hurricane, and that also works really well. This transformer does not separate the mains, so it's everything there is still pretty much dangerous to the touch, but it works very, very well, and it is made to work that way. I was going to use, where is it? Oh, there. I was going to use a variac for controlling the fan speed, but the case of the variac was also getting pretty hot, so I'm not using it. Yeah. So this is a really good improvement, a really good improvement. And even now that it's been running all day, my laser tube is at 23.7 degrees. My water return temperature is at 20 degrees on the outside of the tube. The sensor on the chiller says it's between 16 and 17 degrees. That is exactly the way I want it. And the power of the laser tube has been improving ever since. So it does need run-in, and it's been getting better, a lot better. Maybe I want to spend some more money and get some better lenses, or at least another set of lenses so I can have different focal distances. Yeah, that's about it. Let's have a look inside. So, as I've already shown, my modification of the honeycomb material here, making it black, worked out really well, and with all the soot and all the stuff that's coming off it, it is still black. Even if it were shiny, it's not a problem because it's steel, and steel has a very high absorption rate of the CO2 laser, so that's not a big problem. All that I wanted to get rid of was all of the reflections in there, and I did want to have a better contrast to the material that I put on here. So that's working really well. What I am going to go out and do in the near future is I am going to get a steel sheet to either put on top of here or to replace it, just to improve the airflow, because the honeycomb material is basically a smoke trap. If you laser something and then you lift it up, you will have tons of smoke in the honeycomb material. And if this were a flat surface, all of the smoke would be drawn away, and all of the condensation that you get when you're doing acrylic, for example, would be on that surface, and it is a lot easier to clean it off because you're never going to get it out of the honeycomb. And acrylic, for example, leaves a residue which will ignite, and since I don't want to have a fire in there, I'm going to get a steel sheet that I can place in there when I'm doing acrylic, and when I'm done I can just clean it off, and I'll just be done with it. And if I do wood like I'm doing it here, I can just remove the steel plate and I can do wood. Yeah, basically that is it. I did go ahead and I've cleaned out the grease that was on the linear rails, and I replaced it with high quality grease, and that's been a slight improvement on the loudness and the rattle of the rails. So this thing has a very, very nice sound now. It's basically almost inaudible. You just hear the steppers. There's no more noise coming from the rails, and before there was. So I really like that a lot. And yeah, regarding performance, the machine is still exactly what I needed, exactly what I wanted. I'm very happy that I did get the larger size. The amount of material I've been doing today just wouldn't have been possible with a smaller laser. That is, I didn't think it would be like that, but it really is. So in this case, bigger is better. Yeah, that's it for the updates from the laser. It's a great machine. I love it. And I'm really happy that I bought this. Thank you very much for watching, and bye.